Dear students, let us continue our learning on the course Data Structures and Applications. This is the first session of the third topic of the module 5. The topics covered under this session are hashing, that is basics of hashing, hash table organizations and hashing functions. Myself, Dr. Suresh.d from the Department of Computer Science and Engineering of Canara Engineering College, Bantwal, Mangaluru. First, let us learn what is hashing. So hashing is an effective way to store and retrieve data in some data structures. So when we go at the basics of the hashing, fine. So now let us go with the how we store and retrieve our data in a normal way. So whenever we go for any file organizations, the data will be stored either in the sequential way or in the random way. So when we have stored our data and when we need to retrieve our data, when we go for retrieve the data, fine. So storing, when we get in free space and we are going to store our data. But whenever I want to retrieve my data, I need an efficient way of storing the retrieval of the data. So if I store the data in an efficient way, then the retrieval will be faster. So it is similar to that of how we arrange your books in the rack. If we arrange our books in a proper way, then the retrieving, the searching for the book will be very efficient. If we fail to do that one, I need to search an entire rack to find out my document. The same thing happens with the data storage and the retrieval. If I won't go for an efficient storage, efficiently storing my data, the retrieval of the data will take up the lot of time. So to improvise our storage and the retrieval of the data, we go for the concept of hashing. So that if we store the thing depending on some key value, suppose if it is a rack, so in that rack have a 6 shelf over there. In each shelf I am going to store the textbooks of each subject. So when I go for retrieving that one, so depending on the subject number, I can get my data in an efficient way. I can get the data in the efficient way. Fine. So that will be, that is efficient storage and efficient retrieval. For that one, we go with the concept of hashing. So hashing is defined as a special function. This hashing concept uses a special function called h of x. So where x is our data and we are applying a hashing function over here. So which is used to map a given value with a particular key for the faster access of the elements. For the faster access of the elements, fine. So that is, if I name the subjects as 1, 2, 3 and all. So now what happens? Now the third subject I want to search. So directly I will go with the third shelf. Directly I can search over here. That is, I can leave our first and the second shelf. I can directly search in the third shelf. So or else what happens, if I won't go there, I need to first search all the entries of the shelf 1. Then if I won't found, I need to search for all the entries in the shelf 2. If I won't found, I need to go for the rack 3. Before that one, I need to search these two. Means that will take lot of time. So instead of that one, what we are going to do? So we are going to name the subject simple way. So I am going to number the subjects depending on my subject code. I will going to number the subject. Then once I need to find my data structures textbook. So it is the 32 is my code for the data structure. So now I will go for the second rack over there for finding the content, finding my elements, that is your study materials for the data structures. So that is, I can retrieve the things in a faster way. So for that faster retrieval and the faster storage, we go with the concept of hashing. We go with the concept of hashing. That is, the efficiency of the matching on the efficiency of the hashing is mainly depend on the hashing function what we are going to use. So that is, let us take one simple function. Let me take a simple function as my x mod 10. So this is a simple hash function what I am using. Suppose my number is 123. So I will apply the function as 123 mod 10. So what is my result? It is 3. And if I have a table over here, if I have a table of this arrangement, if I take, then I will go to the index value 3. If I go with the index value 0, 1, 2 and the 3. So the 123 is stored at the index 3. So it is a simple hashing mechanism what I am telling. It's a simple hashing mechanism what we are telling. Fine. So now let me take some random elements over here. So this is a simple one. So now let me take some random elements. My hash function is x modulus 10. And my elements are 11, 12, 13, 14 and the 16. So now if it is my table, the index values for my table will be 0, 1, 2, 3, 4, 5, 6. It will continue till my last index value is 9. So now in this scenario, now in this circumstance, so now when I apply the hash function for this one, my x value is 11. So 11 modulus of 10. What is my result? 1. So now the value 11 is inserted to the position 1. Then my next value is 12. 12 modulus of 10. So which will yield me the result as a 2. The 12 is inserted at the location 2. Then the next value is 13. 13 modulus of 10. So which will give me the value as a 3. That is a 13 is inserted at the position 3. Then the next value is a 14. 14 modulus of 10. Then next I will go for putting my 14 at the location 4. Then next value is a 16. 16 modulus of 10. So now the result is a 6. I will put the 16 at the index 6. Now when I want to, now let us discuss so this is about the inserting. So now when we go for searching the element, suppose if I want to search 13 over here. So in the normal case what happens, I need to search from all the entries I need to search. Now what I will do, 13 modulus of 10. So what is the index value? I will get a 3. I will go to that index, I will get my data. So if I go to that index, I will get my data. Fine. That is for an efficient storage and the retrieval, this concept of hashing is applied. And we should select the hash function in such a way that there should be minimum collision. So how to handle that one? Let us just see how we are going to progress. Fine. So this will be regarding the basics of hashing. Fine. So now if we go for the organization or the concept of hashing, now we are using the two entities over here. The first one will be the hash function. The first one will be the hash function and the hash table. Fine. So these are the two basic entities which are very much needed in the hashing. The one is a hash function, other one is the hash table. So now first let us go with the hash table. Hash table is a data structure which is used for storing and retrieving the data in a very fast way. That is to a quicker storage and the retrieval of the data, we use the hash table. And insertion, deletion and retrieval operations takes place with the help of the hash value. We are going to insert, delete as well as retrieve the contents from the hash table. Hence for every entry in the hash table is associated with one key. So the result of the hashing function is associated with always a key. So now the insertion, deletion or the updations are done with the help of that key value. Using that hash key, the data is retrieved. That is, a retrieved piece of data can be searched in the hash table by few or very few key comparisons. The searching time is dependent on the hash table. That is, the organization, the data structure what we use for building the hash table is very important. Then the next one, hash function. The key points regarding the hash table is it is a data structure for storing and retrieving our data in a faster way. the only key point to be considered in the hash table is the size of the hash table. So lower the size, higher the speed. But a lower number of elements it will accommodate. That also you have to think of. The next one, hash function. So now the hash function is used to put the data in the hash table. If you remember, in the previous example, we have taken 13 mod 10. So mod 10 was our hash function. So 13 mod 10 will yield me the result as a 3. That is, in the index value 3, we are going to insert, delete, search operations was performed. That is, the hash function play a very vital role in the hashing concept. A good hash function should always satisfy these two criteria. Minimum these two criteria it should satisfy. The first one, the hash function should generate the hash addresses such that all the keys are distributed as evenly as possible. There should not be any gap, or let me use the functions as, if I use the terms as 23 and the 13. If I use like this 13 mod 10 and the 23 mod 10. So both are going to the same index value. So what is the result of these two? Result is 3, result is 3. Both are going to the same function over there. This should not happen. Fine. That is, an uniform distribution has to be there. Fine. So in this case, if I use other functions like the 13, I will use mod 7 over here. So 13 mod 7 is a 6. 23 mod 7. This will be 2. The remainder value. So now they are distributed to the, they are put into the other indexes over there. Fine. So this is one such example what we are discussing. Fine. That is, the hash function what we select should generate the hash addresses in such a way that all the keys are distributed evenly as possible among the various cells of the hash table. Second one, it should be the hash function. Don't make that function itself complex. Don't do that one. It should be as simple as possible. These are the two key aspects you have to remember. The first one is the hash function should, when we apply that hash function, the key values what we generate, that should be distributed evenly. That is the first key aspect. The second key aspect is the computation should be as simple as possible. Don't make the hash function itself as a complex function. Don't do that one. The selection of the hash function is very important. Fine. Then let us go look at the types of the hash functions. Different types of the hash functions. Let us see one by one. The first one, division method. In the division method. So in the division method, the hash function depends on the remainder of the division. Similar, same mod operation what I told earlier. Fine. Normally, the divisor is the length of the table. These are the two aspects. Fine. The division, we take the remainder. First point. Then we need the we take the remainder. Then we need the divisor. The divisor is normally the size of the table. Normally, whatever the hash table you are taking, the size of the table will be the your size we are taking for the mod operation. Now let me take one simple example. So now let me take this as the table. So this is using mod 5 operation I am going to apply. So it will have the index values as 0, 1, 2, 3 and the 4. So how many elements are there? 5 elements are there. So the size of the table is 5. Now I have the elements list as a 23, 14, 11, 20, 20. So now I want to insert these values. So how I will do this one? 23 modulus 10, modulus 5. So the remainder over here 3. That is 23 is inserted into the bucket 3. So I made this. 23 is inserted into the index value. Next value 14. 14 mod 5. how much I am going to get? 4. So 14 is inserted here. 11 mod 5, 1. So that is 11 is inserted here. 20 mod 5, 0. So that is 20 is inserted over here. So this type of hashing function, we call it as the division method. This type of hashing function, we call it as the division method. Fine. Then the next one, mid square method. The first one is a division method. Then the next one is a mid square method. In the mid square method, mid square. If you go for the mid square method, first we take, the logic is quite simple. We double the key. We will square the key. That is what the square is. We will square the key. If the key is k, so we will square the key. K square I will make. From that k square, I will, if the k square yield me a result called L, if I take it, we will take the middle of it. We will take the middle of the it by removing the digits from the both the ends. Right? So now h of k will be equal to your L. Fine. So let me take the simple example. If k equal to 2, 3, 4, 5. First I am going to double it, square it. But the squaring this one, I will get the result as a 57, 45, 25. Fine. And my table size is 100. Table size is 100. So what are the maximum elements I can store? 0, 0 to 99. 0, 0 to 99 I am going to get. So now I need a 2-digit number. So I will discard the digits from the ends. 1, 1. So what is left out of 45. So now this is inserted at the index value of 45. So what is inserted? 2, 3, 4, 5 is inserted. So such a mechanism we call it the mid square method. So here the key value is a double squared and the number in the middle of the k is selected by removing the digits from the both the ends. Fine. Then the next method. So this is the second method. The first method we have seen the division method, and the second method is a mid square method we have seen. Then the next one is folding method. The next method is a folding method. In the folding method, next method is a folding method. Here, key is divided into the number of parts. Key is divided into the number of parts, then of same length, except the last part. Then all the parts are added together. All the parts are added. That's what the folding is. So how we will do this one? If it is a key k, it will divided into the number of components over there. Let it be k1, k2, k3, go on up to kn. Then what I will do? I will add them. k1 plus k2 plus k3 continued till the kn. I will add the result. Right? These components h of k will be the additional result. Adding the result, whatever I will get, that is the order. Right? So now let me take one simple example. If my key value is 1, 2, 3, 9, 8, 7, 2, 3, 4, 8, 7, 6. So now what I will do? I will divide into the two digits. K1, K2, K3, K4, K5, K6. Then I will add them. So once I will add them, what is the result? 12 plus 39 plus 87 plus 23 plus 48 plus 76. The total result is a 285. So now this is my key. So now I will go to this index. I am going to insert my element. I am going to insert my element to the index value of 285 over there. Right? So here, if key here, so what we have done, first our key is taken. Key is divided into the number of partitions, and each partitions are added. And each partitions were added, and the added result whatever we are going to get, that will be my key value. That is the index value for inserting my element. That is the index value for inserting my element. Right? So this method we call it as a folding method. First we have seen the division method, next we have seen the mid square method, then the next one is the folding method. Then next one. Now till now whatever we have seen the numericals. If instead of numericals I have a text to store, my name I want to store. In place of numericals, I have my name to store into the table. So in those cases, how to handle them? So for handling them, the fourth method is used. The fourth method is we will converting keys to integer. Converting the keys to integer. Converting keys to integer. If my key is ABCD, let us take. So I will take the ASCII value of the A, 65, ASCII value of the B, 66, ASCII value of the C, 67, ASCII value of the D, 68. I will add them, 68. I will add them. The result is 266. So now this will be my index. This will be my index. Right? So here how we have done? If the key is a string, then the hash value is obtained by converting the string to integer. So if I go for direct conversion over there, it is of 8-digit weight. Fine. So for that reason, what we'll do after converting to the ASCII, we'll add the ASCII values of each character, and whatever the result we are going to get, that will be my index value. And these are the four different methods of the table. These are the four methods of the hash functions over there. What are the method type of the hash function, or the methods we have seen? The first one is the division method, where the simple remainder is extracted over there, and the size will be the size of the table. In the mid square method, second method is mid square. There the key is double, that is your squared, and the middle part is extracted over there. Then the next one is folding method. That is whatever the digit you are going to have, key, that we are going to divide into the number of partitions, and those partitions were added to generate my index value. The next one is converting the keys to the integer. For the conversion of keys to the integer, so that is we will take the ASCII value of those characters, and ASCII values are added to generate my index value. Right? So in the next session, we are going to cover the types of hashing techniques. The references for this video are taken from the textbook Ellis Horowitz and Sartasani, Fundamentals of Data Structures in C, 2nd edition, University Press, 2014, and Data Structures from the Sham Outline series, revised 1st edition, Tata McGraw-Hill, 2014. Thank you.